Hello everyone, welcome to our channel Current IQ. So today we are going through with power system and utilities. What are power system and utilities? I will give you a comprehensive introduction about power system and network. Power system are networks that deliver electrical energy from power plants to houses. The electricity I get it's come from power plants, so there are some steps from power plant to my house. There are few steps that like there are few networks, so we will study about that. So in this presentation I will give you a fundamental of power system design, along with key components and technologies that make up a modern grid. So we will talk about transmission and other uh, operations which held in power system. So in this slide we will talk about transmission network from power plant to substation. So there are power plant and substation. Between these we have a transmission lines. In power plant we produce uh, electricity. Then that electricity we have to send that electricity to our substations. Substations are near to city or in city, but power plants are too far from cities. So the power plants, the transmission line is responsible to carry large quantity of electricity over large distance. From power plant to substation, there is transmission lines or transmission network that carry high voltages or high power. Substation are key sites where power is transformed from high voltage to low voltage. From power plant, we make voltages high to transmit it, but when it reach to substation, the high voltages are converted into low voltages or transform into a low voltages, and we add capacitors to maintain stable power flow and voltage. And now we will talk about stability and security. The transmission network must be designed for engineers to ensure the safety and reliability of the power system. Because we have long lines, we have to protect them, we have to make stable, we do maintenance, we have to control on them, and we should monitor, and we have to monitor in with technologies. We have to control them with advanced control systems. And we will also talk about transmission network in next videos in detail, from basic to advanced, uh, about transmission network or transmission lines. We will drive formulas, we will drive different equations. So now after transmission network, we will talk about distribution network that bring power to us, to communities, to cities, to houses, to hospitals, to industries, to businesses. So after transmission, when we make voltages from high voltages to low voltages, we send that voltages to different transformers and small grids. The distribution networks delivers low voltage electricity to houses, to businesses, and other sites. So there are many factors. We should have a maintenance and safety factor. We have demand management. In distribution network, we will see demand that there are 10 houses, so I have to give that much electricity to them. So if after 10 years there are 100 houses, so I see my peak loads, my signal functions. So we must see the demand management, how much electricity I have to give them, what are their demands. So in this network is spread huge, or this network is so large, so we have to maintain them, we have to ensure the security, the risk of power shortage, the risk of uh, uh, getting equipment get damages, to ensure the reliability. So we should take the good steps while we design a distribution network, or while we are uh, distributing our electricity. So, protecting the grid, ensuring safety. So, we are talking about power system protection. So, from power plant in transmission and distribution, we need protection. In all three steps, we need protection. In all three networks, we need reliability and safety. So, there are different type of protections, and as power system protection we need to isolate and restore the power. There are fault detections and responses. So power system are crucial for detecting and responsible to fault or issue in the grid. We face different issues because of overload, short circuit lighting, and there are many threats of safety of equipments and peoples. So we see fault detection and isolate that thing. The initial thing is isolate the fault and then restore the power from a different part of grids. We will monitor in advance by advanced technologies in grids now. We use smart relays, we use circuit breakers, we use different equipments to secure and to protect our power system. The basic of switchgears protection, control, and isolation. We will just go through with a small this slide, and we will discuss in another videos about switchgears in detail. So we will talk about switchgear components. There are four components: are circuit breakers, fuses, protective relays, and disconnectors. Key features are electrical protection, switching and controlling, and isolation and insulation. It electrically protect, switch and controlled. There are different types of switch gears here: isolated switch gear, gas isolated switch gear, hybrid switch gears, and other. We will talk all about these in next videos soon. Let's have a small application examples of switchgear. Power generation, switchgears are typically used for protection, distribution, and control of power generated by traditional and renewable energy sources. So we just use for protection, distribution, control of power generated by from different energy sources. It's also goes for industrial applications. Switchgears are also initial for many industrial application in manufacturing, mining, and other high power operations. Where the high power operations we need switch gears. So utilities and grids, we know that it's obvious we use switch gears in utilities and grid network. Switch gears is a critical component for utilities and grid operation, allow them to maintain stable and reliable power transmission and distribution network. In this video, we will just take a overlook of transmission, distribution system, and power system. But in other videos, we will go for in derivations, in numericals, and go in detail. So the conclusion is understanding the importance of power grid. So uh, the power grid is a complex and virtual system that plays a critical roles in our daily lives to uh, s- ensure a reliable and safe source of electricity to our homes, business, and critical infrastructure. And in now power grids are active innovations and technologies developed by ongoing efforts to improve efficiency, reduce emission, and integrate new and renewable energy sources. The different companies are working to make smart grids, smart power grids, they are automating them. So, successfully operation management of power grid tech requires collaboration and partnerships among a wide range of stakeholders, including utilities, regulation, consumers, and technology providers, because there are different utilities which are giving you electricity. There are regulations which you have to follow. The consumer should be happy with you that you are giving cheap electricity, you are providing technology to them.